This is project 2, video number 2, the video in which I code up the solution to the problem, write the programs. I've fired up Octave already, and I'm going to browse to the directory in which I want to work. Okay, I found it, and I want to fire up the editor and start writing those functions. So the first function, if I recall correctly, was going to return a variable I called R, and it's I wanted to call it getR, and it had QB, I want to take a look, see if I was using uppercase there. I think, yeah, QB, then XB, a QS for the charge of the particle that's got the smaller magnitude of charge, and XS, and an angle. And I'm going to go ahead and type in the word end so I don't forget that. And then let's see what I was supposed to do here. What I had planned outline of the first function. Oh, I just automatically I right away start calculating what A, B, C, and R are. So 1 minus the quotient of the ratio of the charges squared. So A is equal to 1 minus QB over QS quantity squared. I'll put a semicolon so it doesn't print out. B equals, it was 2 times something, I think it was XB minus XS times the cosine. I've actually got to use cosine D. Cosine by itself assumes the argument is in radians, and then the cosine that assumes the argument is in degrees is called cosine D. So I'm going to go with the cosine D of theta. And then I think C was XB minus XS quantity squared. I gotta check on those. Let's see if I got that right. So, make sure I remember what I put in for them. It was XS minus XB. I think I put it the other way. XS minus XB. That's important there. Here it's not important because it gets squared, so it wouldn't matter. But in the picture I was working with, the arrangement that I had, it was XS minus XB. I had XS, the smaller charge was to the right. Let's make sure. Yeah, XS is to the right. So XS minus XB is going to be a positive value. And then I think the next thing I got to do is calculate R just using the quadratic formula. So R equals, in the numerator, minus B, and then it was minus, we chose the minus of the two possibilities, B squared minus 4 times A times C. B squared minus 4AC. And then that's the numerator. I think I'm going to space that out a little bit. so the parentheses don't get mixed up. So I had open and close parentheses for the square root. Now I got open and close parentheses for the numerator. And that's all divided by the quantity 2 times a, which I anticipate to be negative. Alright. That's what it does. Let's save it. And I gotta save it as get r. I'm gonna Control C. This copies it to the clipboard, and then try saving. And again, I am right where I want to be, I think. Guess we'll find out. So Control V, and it adds the .m for me. There it is, get r .m. And then let's try that. See if it works. I'm going to go get r. See if I get any errors, for instance, that need fixing. And I'm going to try a particle of charge -3 coulombs at a position 1 meter along the x-axis, and then one with +2 coulombs, so that's going to be the smaller charge. So they are opposite charges, and the second one is the smaller. Like it has to be for this function the way it was defined. And I'm going to put that one to the right. And then let's try it at, say, 30 degrees. Gives me an answer. Let's try it at 0 degrees. So it's given me an answer. At 0 degrees, let's try to look at this picture if I can remember. -3, I got a 3:2 ratio for the charges. And to make up for that, I'm going to need a 3:2 ratio for the distances. So, look at this picture, if I can find it. See if I can make sense of it pretty quickly. So I'm over here where the r sub s is going to be right on the axis, and that's going to be at 2. And the distance between these two particles, I think, was 1. And therefore that would make it a 3:2 ratio for the distances, which would make up for the 3:2 ratio of the charges the other way. Let's make sure that distance between the two particles really is, yeah, I had one at 1 and the other one at 2 meters, so 1 meter apart. So I get that 3:2 ratio. So in other words, that does seem like a place where the distance ratio would compensate for the charge ratio. So that's actually looking good. Let's try writing the other one. So I'm going to try create a new one. I call this function. It doesn't return anything. It just draws a graph. So I'm going to call the return variable dummy so that I remember. Anybody looking at it realizes, well, that's probably not used with a name like that. And then the function name plot. I think I wanted to call it plot phi 0. And this was Q1, X1, Q2, X2. And I'll go end for it, and then gotta type in the meat of it. So the one thing was to figure out to assign values to QS, XS, QB, and XB. So here we use I think it's called a program flow statement, the if statement. If a condition is met, we do this, and otherwise we do something else. So if Q1 is greater than Q2, then I do all this stuff. QB is equal to, and that's not going to work for me. I need the absolute values because one's negative and the other one's positive. So absolute value of Q1 greater than, I could put a little space in there, absolute value of Q2. If the absolute value of Q1 is greater than the absolute value of Q2, then QB is equal to Q1, as that is the bigger one, and XB is equal to X1. That leaves QS being equal to Q2 and XS being equal to X2. Alright. Else, so this would be the other way around. I think I'm going to try copying all this stuff and then just modifying it. It could get me in trouble, but I'm going to give it a go. So that'll be 2, 2, 1, 1. And then that's the end of the if-else statement. Let's then try. So I'll take a look back at this and see what I had outlined. It was easier. So I did this part, get the assignment straightened out, and then it's theta is equal to that linspace, get a bunch of theta values, and then the r values, I use that function that I just wrote to get the r values. So theta equals linspace going from 0 to 360 and producing 361 values. Don't print them out. And then R equals get R of QB, XB, QS, XS, theta. Alright, now this is going to be, theta is going to be an array when it passes it this way. So, 361 values rather than just a single value. All these other things are single values, but I think I'm going to do a Control S to save that. And I'm going to cancel because I want to copy the name so I don't have to type it in. There it is. I'll do a Control C to copy it, and then Control S again, and then Control V in there to paste it and save. And there, I've got it. Plot phi 0. Plot all the positions in the XY plane where phi is 0. Then what do I got to do? I wanted to go over to the other function and think about the fact that theta is going to be an array when I actually go to use it. So this is just a number times an array. I don't think I'm going to have any problem doing that. A is just a number. So the thing is, I'm going to need a, well, A is just a number, so B squared. So I'm going to need a dot there. So it does it on an element by element basis. In other words, it's dot squared as opposed to just, or dot to the power of as opposed to just to the power of. And taking the square root of it. I think that's it. So B is going to be an array, but I take the cosine, so that gives me an array, and then I'm just multiplying it by numbers. And then, so it's down here where I square it, but there would be trouble if I didn't have the dot. Doesn't hurt to put too many dots in, extra dots. You know, I could put a dot in front of every single one. That might actually be simpler, but I prefer doing it this way. And then let's go back to the other one. So R is equal to get R of that. And then once I got all the R values, I think I just have to find the X values. So X equals XS plus R times the cosine in degrees of theta. But cosine of degrees of theta is going to be an array of 361 values. R is an array of 361 values. To multiply those together, I need the dot in there. And then Y equals R, or the dot star right off the bat this time. Sine in degrees of theta. Well, it's the sine of theta, treating theta as being in degrees. I'm going to do a Control S, take a look at this because I was just going by memory. So XS plus R, that actually looks good. And then I want to make all these plots. You can do it in one plot command. I think I'd rather do separate plots. So I'm going to go plot X comma Y, and I want to hold. The thing is, I want to do another plot without the first plot being erased. So I'm going to look that up. I think it's hold on. So let's go MATLAB hold. So it keeps it from retain current plot when adding new plots. That's just what I want to do. Yeah, hold on and then hold off. Hold on retains the plot. Hold off makes it so that if you create a new plot, it clears the old. So I'm going to go hold on. Then I do want to make it so that after I get all done, I put the hold off so that when I run the program the next time, it's off. And this will create a new plot if I run it twice in a row. Alright, so I want to plot X big, the position of the particle that's got the greater magnitude charge, and comma 0. Oh, and I want to put a symbol there. And I think I'm going to make it an X. X marks the spot. And then I want to do the same thing with the smaller charge and put an X at that spot too. And let's see what that looks like. Control S. Well, let's see if it runs even. I'm going to try copying this. Control C, and then I'll go to the command window, do a Control V, and I want to edit this. So I think I'll do, if I can remember what I had before, I believe this was maybe 1 minus 3 coulombs at 1 meter, and then 2 coulombs at 2 meters. And I don't put an argument. Oh, there, it's right up here, minus 3, yeah. So that's exactly what I had. And then, let's see what happens. So, it actually made the graph. There's one charged particle at 1, and another charged particle at 2. This was the smaller one, and I got a circle around it. I haven't said, I'm not telling the reader in the graph which one is positive, which one is negative. We weren't required to do that, but I think I want to do a little bit of cleanup here. So it's looking pretty good, except I don't like this starting at 1 and going to 4. That's a false 0, so I'll put a 0 there. The thing is, if this particle is at a negative position, I want to use and the other one's at positive, I use the automatic limits, they call these things. So I think what I want to do is get the limits and set the limits. So let's go. Alright. I actually want to back up a little bit. So for my attribution, I went to used this site for help with hold. I think we'll put that quotes there. And then I want to look up whatever I was working on there, the limits. Get limits, get axis limits. I think that's what I want to Google on. MATLAB, get axis limits. So it goes from what to what? Set or query. So I'm doing a query on the x-axis limits. And I look down here and it's xlim, it looks like. Return the values of the x-axis limits, and this is where they get the x-axis limits. So, and then they're being printed right there. All right. So I'm gonna put that. Well, used. Let's see where I'm at. This URL. For help with axis limits. So I want to make this graph look a little bit better. I'll try to be a little quicker about it. I'm going to save that, and then I could just, there we go. So I did the plots. I'm going to try x limits equals xlim, and apparently it returns a two-dimensional array. I'm going to go ahead and go xmin equals x limits of 1. So the first element of that array is the lower limit on the x-axis. I'm calling that xmin, and xmax equal x limits of 2. And then I think I gotta look at that again. Now I want to set the limits. Set x-axis limits. So this looks like how you do it. Xlim, and then an array with the first element being the bottom and the second element being the top. So you use that same thing, but this time it's setting the limits rather than querying the program as to what the limits are. So xlim of brackets is what the command is. And I want it to be whichever is smaller. The minimum of 0, comma, xlim. So in other words, like the case I had, the minimum value, xmin. The minimum value was greater than 0, and so the graph started at some value greater than 0. It makes the graph harder to read, I think. And I gotta say, that's the minimum value. And then it goes up to, I'm gonna go max, whichever is bigger, between 0 and x max. So if everything is to the left of the origin, then the graph might not go all the way up to the origin, and I want to make it so that it does. So the maximum between 0 and x max. I think I left out a parentheses over here. And I'm on unfamiliar ground, so I think I'll test it. Take a look at the graph. And now it does go from 0 up to whatever the maximum value it needed. It would be nice to extend that a little bit so it's not right up against the edge of the graph there, but I think it's fine the way it is. So I got 2 charged particles there. I would say I should draw a line, like an x-axis going across here, and I'll put a y-axis in case the 0 is somewhere in the middle there. So let's put some axes on there. And in fact, I think I'll just draw a line, and that'll actually set the x limit. So I looked that up, but I didn't need that. I'll plot. From those would be the x values. That's an array of x values, and then my array of y values would just be 0, comma 0. So In other words, I'm going from whatever is the minimum of those 2 comma 0 to whatever is the maximum of those 2 comma 0. So it's all on the x-axis. And do a Control S, try running that again. Take a look. Alright, so that took care of both situations. It does make it go from 0 to 4. It was 1 to 4, I think, before. So it puts a true 0 in there, and it puts the x-axis in there. I like that, a line going through the 0 on there. And let's try running it so it's more obvious that I think I need a y-axis on there too. Well, it's more obvious that we need a y-axis, so I want to run it for a case where I got one charge on one side and the other charge on the other side of the origin. So that'll be x minus at minus 1 meter and at 2 meters. I'll save. Oops, that's the wrong thing to do. So I think that's at minus 1 meters and at 2. Let's try just running that. And then I get this. There's where the y-axis should be, in my opinion. They always put it to the left and to the bottom, but so I'll draw a line through there so it looks like a y-axis. And this will go, I think the y limits have to work the same way as the x limits. So put that there, change that to a y, 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 and then I'll go plot, and for my x values, they're both 0, and for my y values, x min, no y min, comma y max. I'll do Control S and go to the command window, up arrow to call back the last thing that I did. Take a look at the graph, and what do we have? Yeah, I got that 0 line on there. The thing is, these lines are coming in colors. I want them to be more or less like part of the grid. Everything's coming up in a different color. I think I'm okay with the circle being a color, the positions of the charges, but I want to try to change these. So these are plot lines. Let's try MATLAB. I'm googling on or searching on MATLAB line color in a plot. 2D plot. Specify line width, marker size, and marker color. Dash green line, I think. So, I'm going to search on the word color in there. Control F, color. It's marker size. I really want line color, but let's see if marker edge color. How did they make those colors? Okay, it looks like the first one is green, and they used a C for green. specify line style is what we're doing. Line style, color, and marker. So okay, it's B for blue. I want to search on the word color again, make sure. If it's B for blue, then what is it for black? Okay, specifier, what kind of line? Color specifier screen. Okay. Alright. D. I think I gotta say I used both of those. So I used this. My attributions. Alright. Editor. Used Control V. Percent and all I have to do is put a B in quotes. For help with line color in graph. Okay. Plot. It was these two, the last two, comma, K for black, and then comma, K. Let's hope that works. Take a look at the graph. Yeah, okay, I got a black vertical line, black horizontal, and that point where they cross is 0, 0. So this is looking pretty cool. I got a charged particle here, I got the smaller charged particle here, and the locus of all points around that charged particle looks kind of like a circle. I guess the thing is the spacing doesn't always have to be the same between these things. Let's see how that works. Like if I make this bigger, I think I'll try just putting them farther apart. So make that an 8 for instance. Run it. Take a look at the graph. And it actually looks like it's keeping things. Like that's a distance of 5 there. That's a distance of 5 there. But if we make the charges very different from each other. So make this one was the smaller one, smaller amount of charge. I'll make it 0.2 instead of 0.02, a tenth of what it was. Oh, and run it. And here we see the positions get distorted. Like this is 8 meters over, and it's that distance, and the corresponding distance over here is only about 2 meters. I want to make the axes, like the spacing, if that's 2 on this one, then the same distance by I on this one also corresponds to 2. So let's set the axes spacing equal. So let me try axis. This is axis style kind of thing. Well, first off, even though I'm doing it with 2 axes, it's axis. I have to remember that. Axis. And I'm going to search on the word equal. For example, specify the style as equal, axis style, and in the place of the word style, I put equal, to use equal data unit lengths along each axis. I think that's what I want. Axis equal. Alright. Axis singular equal without an S. And I'll save that with a Control S and try running it again. So it makes the circle look tiny, but it really does look a lot more like a circle. So all the points are very close to the smaller charged particle. Now that axis that was supposed to go all the way up and down is not. So I think the limits got ticked off before it got squared. Let's square it first and then pick off the limits. At least try. So axis equal, that's what I mean. That's the command that's kind of squaring it off. Let's put that like right away. I'll try it all the way up here. Oops. There we go. Axis equal. Alright. So save it. Run it. Look at the graph. Alright, so this is my y-axis, the one that goes through the origin, really does extend all the way top and bottom. The spacing here, this distance, looks like about 1 inch on the screen, represents 2, and it represents about 2 here as well. So I think we're in good shape. So instead of that being some big oblong thing, it does look a lot more like a circle, so it's pretty close to a circle there. And when the small charge is really small, the points are real close to it relative to the distance to the big charge. If they're pretty close to each other in size, so 2, let's make them very close to each other. 2.9. They had to be different, was the stipulation in the prompt for this project in the handout. But I can make them pretty close to each other. And if they're close to each other, once again, it always looks like a circle, but now the smaller charged particle is real close to the edge of the circle, nowhere close to the center. Okay, I said I was going to pick a particular arrangement of the charges and see how that worked. I've been messing with different ones. Oh, my plan was, if it didn't work with different arrangements, then I'd have to go back to the drawing board, but it seems to be working with different arrangements, so I've gone, messed around with the size of the charges. If I got the negative charge to the right of the positive charge, actually let's put this one I haven't tried it with both of them to the left of the origin, but I'll put the smaller charge to the left of the bigger charge, but both of them are to the left of 0, 0. So let's see what that looks like. And yeah, it seems like, we're getting the kind of shape, it's going to be some oval. I'm surprised at how circular it looks every time. But here it is with the smaller charge to the left, so I'm always supposed to be circling the smaller charge. Keep in mind, I'm finding this point, that point, that point, that point, etc. all the way around, making the graph. But there are the two charged particles. It doesn't seem to matter which one is negative and which one is positive. Like, I haven't labeled them. You could get a little bit fancy. The project didn't call for it, and I think we've done enough. But you could label them, but it wouldn't affect the shape. Like if I switched both of them, let's try that. So I make the charge that was negative, I make that positive. The one that was positive, I make that negative. The project said, and the handout said they had to be different. And to me, it looks like the same exact graph. So you actually can't tell. It doesn't matter which one is which as far as the sign of the charge. Alright, I think that's enough for coding it up. Seem to have it working. Got to put some titles on the graph and do some documentation. We'll save that for the next video. So I'm going to call this a wrap for project 2, video number 2.